Hello, thank you for taking time to watch this video of my final project for the class Python methodologies. My topic for the presentation is identifying potential areas of Medicare fraud. So to briefly introduce the background of the project, the data is obtained from the real data sources and consists of various details in relation to the Medicare insurance claims like reimbursement rate, patient details, beneficiaries, provider details, claim details, etc. So as a healthcare data analytics student, I am interested in observing the potential fraud by analyzing the data in hand. And now I will show the code and explain how I used Python programming to do that. So the data analysis is not a single step, right? It consists of various sequential steps to obtain meaningful results. So I divided my project into three parts. The part one is data understanding and manipulation. The part two is data merging, and part three is data analysis and exploration. And finally, we will produce the output that shows the findings of this analysis to the screen. So these are the libraries I've used in the project. Mm, Now I will discuss the part one, the data understanding and manipulation. So our data set consists of two types of categories of similar data, the train and the test. So firstly, we have to read all the files, right? So this part of the code will read all the CSV files of the train and test data. And once Python reads all the CSV files, this will print the shape of the data sets, like how many columns, how many rows they consist of, and what types of data they have. And it actually helps us to understand the data, to see the data. And then this part of the code will check whether the provided details are unique or not in the train data. And this part will check the missing values in each column in the beneficiary data. Next, to group the diseases into category and later analyze easily, the diseases are assigned replacing 2 with 0 for chronic conditions. That means chronic condition no is 0 and yes is 1. The following code is not executed right now. However, return to show how I tried using various alternative forms. And regarding this, I'll be speaking successively. And this part of the code I created next to create a new column called age and add to our data. And this will print all the list of the columns to the output CSV file. So this is what I was talking about. Like we can even print the list of the columns after adding the age column to see, whether the column has been added or not, and what are all the columns now we have in hand to the screen. But it is actually clumsy, and if we export the same thing to a CSV file and we can open it, we can easily see it and understand it, and it even saves space of our output screen. So I tried this part of the code to do that, and in the final part, I'll show these two output files. In the next part of my code, we'll flag whether the beneficiary is dead or not using the date of death values. And I have flagged them as 1 and 0. 1 means dead and 0 means not dead. Followed by that, this part of the code will show us the missing values in each column in the inpatient data. And next, I've created this code to check the minimum and maximum values of the days of admissions for each beneficiary from all the data I have. And last part of my data manipulation is to just see the details of the data. I printed everything to the screen after adding all the new variables. So now we have understood the data and manipulated data. The next step is going to be the data merging. In data merging part, I have merged all the similar data so that I can analyze the data easily and derive meaningful results. So 3 to 4 mergings I have done. Firstly, I have merged the inpatient and outpatient data and created better data set for all the patients. So this part of the code will deal with this merging, and I have created it in 2 parts. One for the train data set and another for the test data set. And once I have performed the merging, I have printed the results to see the shape and a glimpse of the data. And apart from the above merging, I have also merged the beneficiary details to all the patients' data. I merged potential fraud details for each provider, and also printed everything, every result of the data merging I have created to the screen. So once I have performed the data merging, now the last step, which is to be performed, is data analysis and visualization. So to make the audience easily understand the results of the data analysis, we have created 6 types of charts to show what we have found. So this code particularly deals with all the different types of charts I've created. And I will show all the output images and CSV files once I finish about explaining the data. And finally, each and every finding will be printed to the screen so that it will be easier to understand what are the findings we have done after performing the data analysis of the existing data set. So firstly, now we will see whether it is going to work or not. So I'll run the program. So this is the output. Firstly, you can see the shape of the data we have, and then the details of all the data, understanding and manipulation we have done onto the screen. You can see minimum and maximum days of admission for each type of data, and finally, the shape of the data after adding all the new layers. And I have even printed some part of the data onto the screen. You can expand and see. And then I have created the charts, which I will show, and these are the findings we have observed. So when we come to the output files created by this program, there are 2 data files created and 6 charts. So firstly I'll speak about the data sets which we have created. So this thing actually deals with the list of columns which we have created to show the output. And finally, the 6 charts. So by looking at these 2 graphs, we understand that proportion of fraudulent claim transactions are more when compared to the non-fraud providers. Easily make distinction here. And the next graph shows the top states with the beneficiary percentage distribution. And here we can easily find state 5, state 10, and state 45 has highest beneficiary percentage. And our next chart is race-wise beneficiary distribution. So here we can easily see that 80% of the beneficiaries are of same race with race 1, and there is no existing race number 4. So when we go to the next chart, this chart clearly shows us that procedure number 9904 has highest potential fraud. And the final chart, which shows that highest potential fraud is associated with claim diagnosis number 4019. So this is all the output created by the final project file. And I sincerely thank for listening to my narration of my project. Thank you.